Hello, my dear students. Welcome back to my YouTube channel. My name is Shakoor Mustafa. Right. So today we will be discussing lecture number 3 of electrostatic. Hello, my dear students. Welcome back to my YouTube channel. My name is Shakoor. So today we will be discussing lecture number 3 of electrostatic. Okay. So let's start now. So we have a couple of students with us right now. Ah, we have Study Tech Bloomers. A very good evening. Then we have Hasana. Good evening, beta. Santosh. Yes. Hi. Good evening. Good evening. Walaikum salam. Okay. So, in previous lecture that we had completed, lecture number 1 and 2, we had discussed about what charges basically are, right? Types of charges and some properties of charges, right? Then in lecture number second, due to some network issue, we had to just keep the lecture short, for I think half an hour. So in the lecture number second, we completed I guess charge density, then some good numerical for your NEET also. Okay, Jasif. Yeah, Regal. Yeah, but I am good. I'm good. I'm good. I'm good, right? So let's start today's lecture. One second. Okay, so you are saying me from which, sir, from which college you are? Yeah, I have passed from NIT Srinagar. Okay. Okay. So these was some numerical that we had done in the previous class. In today's class, we will be discussing Betaji methods of charging. Okay. Santosh, we will discuss it later on, okay? Because you have my Telegram username now, we can discuss these things there only, okay? Just ping me a message in my Telegram and we will just connect you for these issues. So we have lecture number 3 today. So topic would be methods of charging. Methods of charging, right? So now we know that how basically charges get created, by transferring of electrons, okay, or by gaining electrons or by losing electrons. But what processes we had to done so that one element or one atom could lose electron and one atom can get electron? Yeah, I am from NIT, right? Okay, now. So we have basically three types of charging methods. One is friction, one is conduction, third one is induction. Third one is induction. One is conduction, friction, and induction. Done? So look now. Look, we will start with the friction part. We'll start with the friction part. If this is my atom A, this one is my atom B. Sorry, element A or element B, right? Look, beta. It will contain the electrons in outermost shell. Let's say it has three shells. Also, let us go three shells. No, we know that if the electron is in shells, if we want to get these electrons out from the shell, we have to supply some energy. We know it, no? But you can watch my lectures, no? Then you can decide by your own. No? Watch my lecture, then you will decide by your own. Okay? Hello, Subara. Look, if we want to just eject this electron, if we want to just pull this electron out from the element A, we need some energy to get it. In the similar case, if we want to get electron from the atom B, no, we need some energy. That means we have to supply some energy due to which these electrons will get out from their atom, out from their shells. Okay, so we know, yeah, Virat Kohli, yeah, great. So we need some energy, no? When we are just doing friction, let's suppose we are just rubbing our hands. Okay, you just rub your hands, you will feel some sort of heat get generated by friction. What happens now? Heat gets generated, no? Heat gets generated. Okay, so this heat, now heat is also a form of energy. This heat is also a form of energy. Clear? Now this heat gets absorbed by A and B. This heat by get produced by the friction, it gets absorbed by atom A and atom B. Atom A and atom B. Let us suppose the heat that we generated, it is, let us suppose 1 joule. Suppose it is 1 joule, right? Suppose it is 1 joule. And to get out the electron from A, it needs, let us suppose, 0.8 joule. To get electron from B, it needs, let us suppose, 1.2 joule. Okay, the minimum energy required to eject an electron from an atom, this term is known as work function. Yes, yes, beta. Okay, so minimum energy required to eject an electron from an atom is known as work function. Done. I guess the work function of this one is less than work function of this one, na? And we have only 1 joule. So what will happen with this 1 joule? This A will lose electron and B will gain electron. A will lose electron and B will gain electron. Okay, that's how here what A becomes positively charged and B becomes negatively charged. Okay, but the charges on A and B will be the same amount. So I can write charge on A is equals to what? It is plus E, na? Plus E. And charge on B, it would be minus E only. Do you know why? Because beta Q is equals to N times E. Plus E mean that the A element or A atom lose 1 electron. Minus E means the B receives 1 electron. Easy, no? Yeah, if you have any doubt, you can ask me, beta. There is no issue. Easy? Okay. So now we have second type of charging known as what? Conduction. Known as what? Conduction. Conduction means flow of anything. Conduction means flow of anything. Okay, it is conduction. Let us suppose we have a water tank. We have a water tank, no? Okay, look. If we have tank A and tank B, if we have tank A and tank B, what will happen here? Look, you can see now, you can see clearly here that in A, water is more as compared to B. Water in A or height, I can write height of water, na? I can write height of water in A is more than height of water in B. That means now water will flow from A to B. That means now water will flow from A to B. First condition, there should be what? There should be a difference between the heights of A and B. Second part, there should be what? A connection between A and B. Look, if we have the tank is like this now, water won't flow. Why? Because we don't have any medium now. We don't have any way through which the water will flow. So we can write, sir, we have here a pipe. Here what we have is a pipe, no? So now due to this pipe, now water will flow. It is conduction. It is what? A conduction of water. Or if we have a two walls, there will be a conduction of heat. Okay. So for conduction, two properties must be satisfied. One is difference in height, that means potential difference. That is what? Potential difference should be there. Potential difference. Second one, touching. There should be touching, right? If we have potential difference and touching, then there will be a flow of anything, whether it is a water or heat or a charge. This phenomena is known as conduction. This phenomena is basically known as what? Conduction. Easy? And charge will flow from charge will flow high potential to low potential. Charge will flow from high potential to low potential. It is for positive charge. It is for what? A positive charge. But in case of electron, it is reverse. Electron will flow from negative, low potential to high potential. Okay. Just keep this in your mind. Now look, beta. Look. If we have now two spheres. Sphere number A, sphere number B. If we have now two spheres, okay, sphere number A and sphere B. A and B. The radius of sphere A is equal to R1. The radius of sphere B is R2. Charge on sphere 1 is Q1. Charge on sphere 2 is Q2. Clear? Easy? Okay. Now look. Let us suppose they have different potentials. Here we have potential V1. Here my potential is V2. Potential is different. Potential is different. So before charge transfer takes place, we have to make them touch na, by body to body, or let's suppose we just connect them with a wire. Let us suppose we have here a wire na. So I will just make them a touch with a wire like this. Okay. Now with this wire, what will happen now? Charge distribution will take place. Charge transfer will take place from high potential region to low potential region. What will happen now, beta? Look, I will make the second diagram for the same, right? Look here. 1 and 2. Charge will flow until and unless the potential will become now same. So the potential, if the potential of A will become V now and potential of B becomes V now, charge transfer will stop now. Charge transfer will now stop now. Why? Look, beta, in uppercase, when the height of the two bodies will be same. We have pipe now. If the height of the two A and B tank will be same, now there won't be any transfer of water from A to B or B to A. Why? Because equal height in both A and B. That means equal potential. So there won't be any sort of what? Conduction. For conduction, two properties should be satisfied. One property, there should be a potential difference. Second property, there should be a conduction. Okay. Okay, now let us suppose after conduction, the charge on A body is what? Q1. And charge on second body is Q2. What is the formula for potential? Sir, potential is equals to K charge. Charge is Q1 by R. You will just learn this formula later on, okay? That means the potential for A is equals to K charge Q1 by R, R1. Potential on second would be K Q2 by R2. Done? So that means potential V is equals to V. We know it now. Potential same. That's why charge transfer stops here now. So what is this? Sir, I can write it is K Q1 by R1 is equals to K Q2 by R2. K get cancelled out, so I can write Q1 by Q2 is equals to R1 by R2. This is my relation. More radius, more capability to hold charge. More radius, that means more capability to hold charge. If we have a sphere with 2 meter radius, we have a sphere with 4 meter radius. The sphere with 4 meter radius will have more charge as compared to the A body. Okay, more radius, more charge. Done? Okay, and we know one thing. Now, beta, look, we know one thing. What? The summation of charge initial is equal to the summation of charge final. Conservation of charge. So then can I write now? Sir, initial charge. Can I write now? Initial. I will write initial, no? Initial charge must be equals to final charge. Initial charge must be equal to final charge. Sir, what is initial charge? It is Q1 plus Q2. Sir, what is final charge? It is Q1 plus Q2. Done? Look, from this particular equation, I will get my Q2. I guess Q2 is equals to, it is R2 by R1. Then it is Q1, no? It is R2 by R1, then Q1. So I will place the formula here. Now look, I can write Q1 plus Q2 is equals to, in place of Q1, I will write Q1 plus Q2. What is Q2? It would be R2 divided by R1, that is Q1. Done? So what I can write here? Now I can write Q1 plus Q2. I will take Q1 common. Now what I have here 1 plus R2 by R1. Done? Look now. So I need to get my Q1 value. So what my Q1 value is? Sir, my Q1 will be equals to how much? It will be equals to R1. So I can write from this one, look beta. I can write Q1 plus Q2 is equals to Q1. Then I have R1 plus R2 whole divided by R1. So if I need to Q1 now, so Q1 is equals to R1 whole divided by R1 plus R2. Then I have multiplied it with by Q1 plus Q2. Okay. What will be the net charge after conduction? This is the formula to calculate it. And similarly, I will calculate my Q2. So Q2 is equals to R2 divided by R1 plus R2. Then what we have? We have Q1 plus Q2. These are my two formulas by using which I can get my answer. If you have any doubt regarding the conduction part, you can ask me now. Okay? If not, then we can discuss furthermore. This is very easy, na beta? This topic is very easy, na? I know it needs some sort of minute, na? It needs 30 seconds, na, to just ask your doubt, na? Okay. I guess now there is no lag now. There is lag, some sort of lag right now. Okay. Let me check. Yeah, there is lag once again. Now better now. Okay, look better. So we have no special cases now. We have some special cases now. Look, special cases now. We have some special cases. Let us suppose we have identical spheres. Let us suppose we have some identical sphere, and 90% numerical you will be getting identical spheres only, no? Identical sphere means identical sphere. An identical sphere means if radius is equal, R1 is equals to R2 equals to R. If we have two spheres with the same radius, we will call it as an identical sphere. We will call them what? Identical sphere. Okay. Look better. Same procedure if we have one sphere with radius R. Okay. Second sphere with radius same R. So how it is charge is Q1, charge is Q2. Now I will just make them conduct. Now new charge will become Q1 and Q2. How to get Q1, Q2? We know the formula, na? So we know, sir, Q1 is equal to how much? It is R1 whole divided by R1 plus R2. Then it is what? Sir, Q1 plus Q2. So if R1 is R equals to R2, now both are R. So I can write Q1 is equals to R divided by R plus R. Then we have what? Q1 plus Q2. Or I can write, sir, Q1 charge will be equals to R plus, it will be R divided by 2R. It is Q1 plus Q2. R cancel out. So finally I have Q1. So Q1 will be equals to Q1 plus Q2 divided by 2. Okay. And similarly, my Q2, no? My Q2 will be also equals to Q1 plus Q2 divided by 2. Look, if we have same identical spheres, so the charge will be what? A mean of them. Charge will be a mean of them. Okay. It will be Q1 plus Q2 divided by 2. So let us do some numericals now. Let us do some numericals for a practice problem. Okay. Let us do some numericals on it. Look now. Look beta. Let's do some numericals. Now let's suppose we have a question. One sphere, radius R, but charge is 3 Coulomb. Second sphere with radius R, but charge is -1 Coulomb. If we make them touch, then separated. If we make them touch and separated, find final charge. Find final charge. That means we have to find what? We have to find Q1 and we have to find Q2. Look beta, this is purely a case of what? Identical sphere. So how we can do it? Sir, we know now that Q1 is equals to Q1 plus Q2 divided by 2. In the same way, sir, Q2 is equals to Q1 plus Q2 divided by 2. Sir, Q1 is 3 Coulomb minus Q2 is 1 Coulomb divided by 2, right? Similarly, Q2 will be equals to 3 minus 1 by 2. Sir, why minus here? Because on the second, now we have minus now. Done. So it would be Q1. This is my Q2. So I guess my Q1 will be equals to 3 minus 1. It is 2. 2 by 2 is 1 only. Now, beta. So I will get 1 Coulomb and Q2 is also equals to 1 Coulomb. So the final charge on these spheres will be 1 Coulomb and 1 Coulomb. Easy, no? The final charge on this sphere will be 1 Coulomb and 1 Coulomb. This was a case of identical spheres. Now let us do a numerical with different radius also. Okay. Okay. I guess you have done capacitor, no? Is there anyone who had done capacitor? Is there anyone watching who had done capacitor chapter? The capacitor one? Huh? There is some question. Now look, if we have the plate is like this, no? Charges plus Q, charges minus Q. So we are assuming that whole charge is on the inner wall. Whole charge. Why not here? Okay. The answer will be from this particular slide. Okay. For capacitor, na beta? For capacitor, you will get the answer from this particular slide, na? Okay. Yeah, when we will doing capacity, I will make you understand how we can do the summation of charge only on the inner wall, not on the outer walls. Okay. Okay. Next numerical. Let us do a next numerical. 1 second. Let's do a next numerical. And next numerical will be like, we have a sphere now with a radius 2 centimeter. One more sphere with a radius 3 centimeter. Both are connected. Both are connected by a conducting wire. Then calculate new charges on each sphere. You can see here, radiuses are not different. And charge on Q1. Q1 is given to be, it is 5 into 10 to the power minus 5 Coulomb. And charge on second is equals to minus 3 into 10 to the power minus 5 Coulomb. Look, charges are different. That means we cannot use Q1 plus Q2 by 2 formula. We have to use the previous one. Q1 equals to R1 divided by R1 plus R2 multiplied by Q1 plus Q2. So how we can get it? Look, how we can get my answer now? Look, beta. So what is Q1? So Q1 formula is R1 divided by R1 plus R2 Q1 plus Q2. So what is R1? Sir, R1 is 2 centimeter. So I have to change centimeter into meter. So I can write 2 10 to the power minus 2 meter. What is R1? R1 is 2 into 10 to the power minus 2 meter plus R2 is 3 into 10 to the power minus 2 meter. Look, it is 3 10 to the power minus 2 meter. This will become 2 into 10 to the power minus 2 meter. Okay. So Q1, what is Q1? Sir, Q1 is given to be 5 into 10 to the power minus 5, no? Is it minus 5? Minus 5. It is minus 5 Coulomb plus minus 3 into 10 to the power minus 5 Coulomb. So I guess it will get cancelled out now. Yes. So my Q1 is equals to, it is 2 divided by 2 plus 3. I will take 10 to the power minus 5 common, then I have 5 minus 3. So it is 2 divided by 5. 10 power minus 5. Then what we have? 5 minus 3 is, it is 2. So Q1 will equal 2 to the 4. It is 4 by 5. 10 to the power minus 5. Coulomb, right? If we want to simplify it, so what I can do here, beta? Look, I can write 4 by 5. Now, I can 4 by 5 is equals to how much? 4 ones are 5 ones are 5. It is 0.8, no? 0.8. It will be 0.8 into 10 to the power minus 5. So I can write it is 8 into 10 to the power minus 6 Coulomb. So the final charge on the sphere 1 will become 8 into 10 to the power minus 6 Coulomb. We have to apply the same procedure and we will get our final charge on the sphere B also. Done. And how we can get it? By using the same formula. How, sir? Look, Q2 is equals to R2 divided by R1 plus R2, then Q1 plus Q2. What is R2? What is R2, beta? R2 is 3 into 10 to the power minus 2. What is R1? 2 into 10 to the power minus 2 plus 3 into 10 to the power minus 2. What is Q1? Q1 is 5 into 10 to the power minus 5 and it is 3 into 10 to the power minus 5. Look here, cancel out. So I have 3 divided by 3 to 5, 5. Then 10 to the power minus 5. Then what do we have? 5 minus 3. I can write 3 by 5 minus 3, 5 minus 3, it is 2. So I can write 2, 10 to the power minus 5. 3 to the 6, 6 is by 5, 10 to the power minus 5. So my answer is 5 on the 5, 5 to the 10, 1.2 10 to the power minus 5 Coulomb. This is how we can get our answer of Q1 and Q2. Easy? Easy, beta? Okay. Now we know how to tackle the problems if the same radiuses are given. We know now how to tackle the problems if different radiuses are given to us. Okay, and if charges are given to us. Let's suppose we have a numerical in which not charge, basically charge densities are given to us. If we have some numericals in which charge is not given, but instead of charge we have given charge densities. By using charge densities, we have to calculate charges. Do you know what is charge density? I guess in the previous class, we have discussed charge densities. Charge density is 3 types: linear, surface, volume. Linear charge by length, surface charge by area, volume charge by volume. Okay? Look now. Let us suppose we have a question here. We have a question here, no? And question is like, one sphere, one more sphere. Okay? And radiuses are given to us. So this radius is 2r. And this radius is how much? It is r. Suppose, no? And on this one, we have sigma. Sigma charge density is given to us. Here we have 2 sigma. Okay. What is sigma, beta? Sigma is surface charge density. It is what? Surface charge density, and which is equals to charge by area. Charge by area. This one, no? Okay. So if sigmas are given, charge densities are given to us. जितेंद्र बेटा, मैं अपना टाइम वेस्ट नहीं कर रहा हूँ, ठीक है? अगर एक बच्चा भी देख रहा है तो कोई बात नहीं, वो तो सीख रहा होगा ना बेटा। और कोई एक बच्चे को भी मेरा एक पॉइंट समझ आ रहा है तो बस मेरा तो यही काम है एज अ टीचर। मेरा क्या मानना है यहाँ पे? If a student is getting iota of the things from my class, no, that is the motive of my class. Okay? मैं ये नहीं चाह रहा हूँ कि आप 1000 यहाँ पे लाख बच्चे यहाँ पे आ जाए, नहीं, एक बच्चा भी आ रहा है वो मेरे लिए सफिशिएंट है, कोई इशू नहीं है ना, कोई इशू नहीं। Okay. Now, if charge densities, now if instead of charge we have charge densities, right? So how we can do it now? Look at it. For this one, I can write sigma is equal to charge. Let us suppose charge is Q1. But area, what is area? What is area of this one? Sir, it is 4 pi r square. I can write 4 pi r. R is 2r square. So it will looks like Q1 divided by 4 pi. It is 2 to the 4 for 16. Nah, it is what? 16 pi r square. For this one, no? For this one, what I can write? I can write 2 sigma is equals to Q2 whole divided by 4 pi r square. So by this simple manipulation, I got my charges, initial charges in terms of sigma. It is sigma 16 pi r square. This one, I can write my Q2. It is 4 to the 8. Look, it is 2 and 4, 4 to the 8. I can write 8 sigma pi r square. 8 sigma pi r square. Now we have to calculate new charges. What we have to calculate? New charges. New charges. So we have the same formula now that we used in the previous class. That is, sir, Q1 is equals to R1 divided by R1 plus R2. Then we have Q1 plus Q2. We can use it now. What is R1? Sir, R1 is 2R. R1 is 2R plus R2 is R only. Q1 is how much? It is 16 sigma pi R square. And what is Q2? It is 8 sigma pi R square. 16 plus 8, 24. It is 2R plus 3R. Then we have 24 sigma pi R square, right? R cancel out. So we have 3 1 the 3, 8. 8 to the 16. So I have Q1 is equals to how much? 16 sigma pi R square. In the same way, I will calculate my Q2. And Q2 is equals to R2 divided by R1 plus R2. Then I have Q1 plus Q2. What is R2 beta? R2 is R and R1 plus R2 is 3R. Q1 plus Q2 is 24 sigma pi R square. 3 1 the 3, 3 8 is the 24. So my Q2 came out to be how much? It is 8 sigma pi R square. Now, if charges are given to me, so we can get our answer, na? And if charge densities, if these things are given to us, we can get our answer better. Simple, no? Simple. Look, beta, if you can see from here, no, look. Final charge is 16 sigma pi r square. Initially, it is also 16 sigma pi r square. Here, it is 8 sigma pi r square. Initial 8 sigma pi r square. That means no charge transfer takes place. No charge transfer takes place. Okay? So I can write here, therefore, no charge transfer takes place. Why? Because there was same potential. Same potential. Okay? Done, no? Now let us derive a shortcut method. How we can get the relation between charge density and the radius. Let us derive a formula for shortcut, no? For shortcut purpose, let us derive a formula for a shortcut purpose for our competitive examinations. Look, we have two bodies. Done. With charge Q1 and Q2. We make them touch, then final charge becomes Q1, Q2. Radius R1, R2. Sigma 1, sigma 2. What is sigma 1? Charge. Charge by area. Charge by area. What is final charge here? I think final charge is Q1. What is the area? It is 4 pi R1 square. Sigma 2. I can write Q2 divided by 4 pi R2 square. Let us divide these two, right? So we have sigma 1 Q1 by 4 pi R1 square. Sigma 2 Q2 divided by 4 pi R2 square. One more thing that we know from the previous one, na, that Q1 by Q2 is equal to how much? R1 by R2. We know this thing, okay? So now, let us divide these two now. So look, 4 pi cancel out. So we have sigma 1 by sigma 2 equals to Q1 whole divided by R1 square equals to R2 square divided by Q2. Okay? I can write Q1 by Q2 multiplied by R2 divided by R1 whole square. So I guess I can write R1 by R2, Q2 by Q1 also. So I can write sigma 1 by sigma 2 is equals to Q1 by Q2. Then I can write it is, look, from this particular equation, I can write R2 by R1 as a q2 by q1 whole square, square. One cancel out, one cancel out. So therefore, sigma 1 by sigma 2, I can write it as a q2 by q1. I can write it as a q1 by q2. I can write it, no? And q is proportional to the r. Therefore, I can write it equals to sigma 1 by sigma 2 equals to r2 by r1. That is, sigma is inversely proportional to the r also. Sigma is inversely proportional to the r. Clear? So this is a shortcut method. This is what? A shortcut method. Done? Why is there lag now? Let me check. This is how we can do it, no? Very easy, no? Very easy. Okay. Now we have last topic known as what is time? Sure. Okay. Now one more property, third one, that is charging by induction. Charging by induction. Charging by induction. Third type of charge, charging by induction. Okay. So what will happen now if we have a charge here plus q? Now here I have a neutral body. I have a neutral body. Now I bring this neutral body closer to this one now. Due to this positive charge, it will attract a negative charge here. And it will push positive charge here. Settle, this body is neutral. Settle, this body is neutral. Now, what will happen now? I will apply a earthening here. No? Let's suppose I will do what? Earthening here. Earthening. So, due to earthening, what will happen? Na, beta? Due to earthening, what will happen? Minus charge will be there, no? But positive will transfer here. Now, next step, what I can do here? I will take the earthening, no? Look, here is positive charge Q. Here I have my negative charge. Now I will take my negative positive charge also. So now I have my sphere with negative charge only. It is charged. It is what? Charged. So look, initially it was uncharged. It was neutral body. Now placing a positive charge, it will attract a positive and it will repel positive. Attract negative and repel positive. Now we have applied earthening. Due to earthening, positive charge goes into the ground. Why? Because low potential, no? Assume a 0 volt, low potential, it will go inside the earth, right? Now we have a positive and negative. Now when we just take positive also out, no, then a negative charge will spread over the surface uniformly. So it becomes a charged particle now. This becomes now a charged particle. Okay? Okay, let's do some numerical, then we can just wrap up our class now. Look. If we have a rod like this, one rod, charge on this rod is plus q, charge on this rod is minus q. And we have to find charge on phase 1, phase 2, phase 3 and 4. Look, charge on phase 1 will be equals to charge on phase 4. And how to get it? Sum charges divided by 2. That means we have 2q minus q by 2. It will become how much? Q by 2. That means on this particular side, we will have q by 2. On this side, we will have q by 2. Now, total charge is 2q. On this side, we have q by 2. What will be the charge on second? So, total charge is 2q. I will minus it by q by 2. So, we will have 4q minus q by 2. So, we will have how much? 3q by 2. So, on this side, I will have 3q by 2. Due to induction, this will have a same charge but negative. Now, it is minus 3q by 2. Now, if you add these two, now you will get minus q only. You will get minus q only. Okay, this is how induction works. This is how induction works. Okay, let us do one more numerical. Let us do one more numerical. And the numerical is like, look, I have q charge on this one, minus q charge on this one, 2q on this one. Find charge on 1, 2, 3, 4, 5, 6 faces. Look, just add these. Now I can write q minus q plus 2q whole divided by 2. Q cancel out. I have 2q by 2, which is q only. So on this side, I have q charge. Total charge is q. On this side, I have q. That means on this, I have 0. If on this 0, so it will have 0 here. Look, total charge is minus q. On this plate, I have 0. So whole charge will be on this side. If I have minus q here, due to induction, it will have plus q here. Total charge is 2q. I have q here, so it will have plus q here. Look, q plus q, 2q, minus q plus 0, minus q, 0 plus q, q. Done? Easy? Easy, no? So let us do now some numericals, PYQs, okay? Let us do some PYQs. We have a PYQ from IIT. That is, we have two spheres. We have two spheres with plus 3 electron charge and plus 8 electron. R is same. That means it is a case of identical sphere. What will be the charge at the final? So look, I will write Q1. So Q1 will be Q1 plus Q2 by 2. And similarly, Q2 will be equals to Q1 plus Q2 by 2. Look, Q1 is 3E, Q2 is 8E by 2. Similar, it is 3E plus 8E by 2. So look, 8 plus 3, it is 11E by 2. It is how much? 11E by 2. It came into fraction, which is not possible. So how it will be possible now? So I can write it as a what? Sir, 5 electron plus 5 electron plus 1 electron. That means this will have now 5 electron, 5, and 1 electron will do oscillation. 1 electron will do oscillation. Oscillation between 5 and 5. Okay. This was a numerical asked in IIT. Okay, beta? Some tricky one, na? So tricky one. Okay. One more numerical from NEET. I'll do one more numerical from NEET. We have a sphere with a radius r, charge 120 microcoulomb. One more sphere with a radius 3r, charge is 60 microcoulomb. So find final charge after conduction. I guess Q1 is equals to R1 divided by R1 plus R2, Q1 plus Q2. R1 is how much? It is R only. Then it is R plus 3R. Q1 plus Q2 is 160, 120 plus 60, 180. So it is 180, 10 to power minus 6 coulomb. So look, I can write R by 4R into 180, 10 to power minus 6. Cancel out. So what we have? 180 by 4, 10 to power minus 6. Done. 4 ones are 4, 4 for 16, 20. So my Q1 came out to be 45 microcoulomb. Q1. In the same way, we can find Q2. Q2 is how much? It is R2 divided by R1 plus R2 into Q1 plus Q2. So look, R2 is how much? So it is 3R. R1 plus R2 is 4R. Here it is 180, 10 to power minus 6. Cancel out. 4 ones are 4, 4 for 16, 4 for 20. It is 4R into 3. 4R into 3, it is 135 microcoulomb. This is how we can do these numericals. Done? This is how we can do numericals, okay? Let us do a couple of numericals more, then we can stop our lecture. Okay, look, one more numerical from IIT. One more numerical from IIT. It is, we are touching. We have spheres. Sphere A, which charge plus Q. Sphere B, which charge minus Q. Sphere C, which charge 0. We are touching A and C. A and C. If we are touching A and C, B charge will become minus Q as it is. A and C. A and C. So I can write A plus C. So it is plus Q plus 0 by 2. It is Q by 2. Q by 2 here, Q by 2 here. Now we will touch B and C. We will touch B and C. B and C. A will become as it is Q by 2. B and C. B and C, that means minus Q plus Q by 2. It will become how much? Polar 2, no? It is minus Q by 4. It is minus Q by 4, minus Q by 4. Let's say we have A and C. A and C. B will come as it is minus Q by 4, A and C. A is equals to Q by 2 minus Q by 4 whole divided by 2. It will be equals to Q by 8. Q by 8, same Q by 8. Okay. I have used the if you have any doubt, you can ask me here now. Related to induction, conduction, friction, you can ask me, or related to charges also. You can ask me, okay? There is no issue. So this is how we can do these numericals. No? I just completed this one very fast. Why? Because we had discussed the same one in the previous class. Sorry, in the previous topics also, right? So okay, so there is a question: if we can find electric field due to disk by deriving it through rings, okay, with integration, how can we find it through it by rotating a rod instead of rings? Look better. If you have done the case of rotation motion in your 11th, so if we just press the rod, it will become disk then. Okay. If we press the rod, it will become disk then. Done. And this one is not in your syllabus also. Electric field by disk, it is not in your syllabus. But still, I will do these cases in my lectures. Be the lecture, right? No issue. Okay, look now. Look better. Suppose here my charge is plus 3 coulomb. Here is minus 8 coulomb. Here is plus 11 coulomb. Here is minus 6 coulomb. Split it now. How we can get it? Simple. Just sum all charges. 3 minus 8 plus 11 minus 6 whole divided by 2. 11 plus 3, 14. 14. 14 by 14 is 0. So my answer is 0. That means here I will have 0 charge, 0 charge. Now whole charge is 3 coulomb on left side 0. So whole charge will be here 3. 3 by induction I will have minus 3 here. Minus 8 we have minus 3 now. It is minus 5. Minus 5 here I will have plus 5. Plus 5 then I have plus 6. Plus 6 then I have minus 6. Okay, minus 6 is 0. Minus 6 is plus 5. Plus 6 is plus 11. Minus 3 minus 5 minus 8. 0 plus 3 3. Easy? Okay. Let us do one more now. Look. I have a shell with a radius r. With radius, I have placed a point charge here, minus q. and the charge of the ring or the shell or this sort of shell is plus q. Is plus q. How to find sigma? Sigma of inner one, inner layer. Sir, sigma is charge. So on this inner layer only, I have charge of this particular by induction minus q. So I will have what here? Plus q. So I can write, sir, plus q divided by 4 pi r square. What is sigma for outer one? Outer layer? Look, if here I have plus q, so here I should have minus q. Okay, so I will write, sir, it is plus q minus q divided by 4 pi r square. This is how we can write it. This is how we can write it. Okay, if we have a metallic cavity, the sort of disc also, okay? If we have a metallic disc, look, material. If we have metallic disc, no, with radius A, with radius B, and at the center I have a charge of minus q, and outer I have charge of plus q. So how to write sigma? Sir, sigma for inner one by induction. If this is negative, so I will have positive here, plus q here. So I can write, sir, plus q divided by 4 pi a square. Sigma for outer one. For outer one, I can write what? If plus q here, I will have minus q here. So I can write what? Q by q divided by 4 pi b square. This is how we can write sigma. Adarsh Yoda. Better look. I will give you one simple sort of idea. Now look. Here I am teaching for JEE or NEET and as well as boards, right? So I will teach as per the curriculum released by the NTA and the JEE one. Okay. If you are interested in exploring new opportunities, if you are interested in exploring new different ways of thinking how the real world works, right? You can do one thing, you can do BSc simple in your physics or in your maths, right? Honors. Then you can do MSc, then you can do research. Nobody will just keep you back, no? If you want to do research, if you want to be in a research field, no, and if you think now you will use maximum efficiency there only, no, you have to opt for research field also. Okay, we have to be a constraint, no, regarding the levels. Okay, let's suppose you are asking me some numerical. Okay, you are asking me some aspect of, sir, how, let's suppose if we have like this and if we do like this, how it will help, no? So I will give the class, no? It will not benefit the core of my students, no? Look, my students score those belongs to NEET and JEE, right? And if and you want some research thing, right? You can go there. There is no issue. You can opt for research programs. You will get their great knowledge, no? It is basically, no. It is not. It is basically, no. What to say? A way of thinking, no. I have my own research paper also. Okay, there is no issue. On international level, I have my own research paper. Okay, it is not like that. I am just having the JEE NEET also. Okay, look, but I love these things to be in it. No, I don't want to be in a research field. That's why I came here. But if you want to be there, no, there are a lot of opportunities you can explore. Then you will maybe you will get Nobel Prize for physics or for chemistry or for maths, right? So not for maths, for chemistry and for physics. Okay. So I guess we are done with today's class. So what we can do, no matter what we can do in next class, we will study Coulomb's law. Okay. That is all for today's class. And thank you, Beta. Thank you very much. Bye.